suppose we want to evaluate this expression for x equals 2 using strict order of operations, which is my rule in pretty much all of my classes. Okay, so how are we going to do that? Well, first we look at this big long expression, not that long, but long enough. We're going to have to substitute 2 for all x's. So we're going to write out the expression, putting a 2 in for every x, then we'll figure out what to do next. So let's just start by writing out, okay, x is 2 plus 5 times 2 minus 3 raised to the third power minus 2 over 2 plus 3 raised to the negative 2 times 6 plus 1. Now my spacing here is just incidental, but you know, sometimes you leave a longer space between one symbol and the next, sometimes you don't. Okay, so what do we do first? Well, if you understand the order of operations, then you know that we have to do all exponentiations first. So the first thing we need to do if we move from left to right is negative 3 raised to whatever power. Now what power do we raise negative 3 to? Is it to the 3 minus 2, or is it to the third? Well, if we do 3 minus 2, we've done a subtraction. Subtraction can't come before exponentiation, raising to a power. So we have to raise negative 3 to the third power. Well, negative 3 to the third power is negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is 9. Multiply that by negative 3, you get negative 27. So this term here is now minus 27. And then in front of that, we're going to have the 2 plus 5 times 2, and the whole minus 3 times 3 to the third is negative 27. And then we do this exponentiation. And again, we do 3 raised to the negative 2, not to the negative 2 times 6, because we can't do this multiplication since we have this exponentiation here. So 3 raised to the negative 2 is 1 over 3 squared. And I'm going to write it that way. I'll simplify that. In the next step, I just want to emphasize that that's what negative exponent means. Then we have minus 2 over 2, and then times 6 plus 1. And we have a plus here. It's a plus 3 times, or plus 3 raised to the negative 2. Okay, well that's so far okay. Now we do multiplications and divisions in order. So we do the multiplication here, and it's now 2 minus 27. It's 5 times just 2, not 5 times 2 minus 27. We want to do 2 minus 27, we put parentheses here, and we could have, of course, then put parentheses here. But that's not what was intended, that's not what was written. So we have 5 times 2, that's 10, and minus 27. And now here we've got a division, 2 divided by 2, that's just 1, plus, okay, now 1 over 3 squared. Now, strictly speaking, we should have done the exponentiation here before we did all of this, but I could have easily written this as negative 1/9 in the first step, so I kind of violated my own rule here. But I'd have this intermediate step in here just to clarify what the negative exponent means, because that's often a real hang up for people. Okay, so here we have it. Now, what do we do next? Well, we have to do this multiplication. And we've got an extra step here because of what I did there, but that's okay. We have 2 plus 10 minus 27 minus 1 plus, well, that's 6/9. Okay. Next, we do additions and subtractions in order. We're going to get 12 here, and then minus, now the way I want to do this, minus 27 minus 1 is negative 28, so it's legal to do this. And then we have plus the 6/9 plus 1. Now, I'm actually going to use the commutativity of addition to write that as 1 plus 6/9. And now I can do 12 minus 28, which is negative 16, add 1, which gives me negative 15, plus 6/9. That gives me negative 16 and 6/9, a mixed number. And that equals negative 15 and 2/3. Because you can divide both the 6 and the 9 by 3 to give you the 2/3. More about reduction of fractions when we do some prime factorizations. Okay, so there's the expression, and I hope I've done it correctly. If not, somebody please let me know. And this is strict order of operations. I'm going to do the expression one more time, but I'm going to introduce some parentheses just to illustrate. So if the expression was 6 or x plus 5 times x minus 3 to the third minus x over x plus 3 raised to the negative x, I ran out of room, but I'm going to do it here, times 6 minus 1. Then, when I substitute 2, I'm going to have 2 plus 5 multiplied by 2 minus 3 raised to the third minus x over x. It's not x, it's 2. Looking more at the space I have than what I'm writing. Okay, 2 over 2 plus 3 raised to the negative 2. And I intended to put parentheses around the 6 minus 1 and at negative 2 should be written here. Okay. Excuse my carelessness. Okay, so here we have it. Okay, so what do? Well, we do what's inside the parentheses. We have 7 times 2 minus 3 to the third. Well, that's going to be 2 minus 27. And then we have minus 1 plus 1/9 times 5. Now I've kind of mixed things up a little bit. Evaluated inside the parentheses here, but then I went ahead and did an exponentiation over here. At the same time I did this subtraction strictly. That exponentiation should have been in another step. And, well, this one needs to be in this step. Okay, but I haven't violated any rule. So that gives me 7 times negative 25 minus 1 plus 1/9 times 5 is 5/9. And 7 times negative 25 is negative 175 minus 1 plus 5/9. And that's negative 176 and 5/9. And the point of order of operations is if you're typing mathematics into a computer keyboard, you can get all fancy and you can put exponents and fraction bars and everything, but it takes a long time. And you never do that with mathematics software. If you're entering this expression in one way or another into the typewriter or into the keyboard, you use this keyboard notation. Everything has to be on a line. And the keyboard notation has an advantage in that it focuses you on what operation is being done. You're not using visual cues. I could have written this well, in this case, there's really not another good way to write it. I mean, I could have written it as x plus 5 times x minus 3 raised to the third power minus x over x plus 3 to the negative x times 6 minus 1. And in many ways it might be a little clearer what you do with this notation. But if you go by visual cues, you can easily be misled. And we'll see plenty of instances in which this can happen. The main point here is we use strict order of operations when we're asked to do so with expressions written in keyboard notation.